Okay, so now we're going to move on to look at differences between groups. And this is where we would have categorical data for one of our measures, the measure, the predictor, or the independent variable, and we have continuous data as our outcome or our dependent variable. And that allows us to look at differences between groups. This little figure here in front of you on the screen is how we consider the types of tests that we can run when we do have these two groups with continuous outcome measures in them. So if we work our way down, we have our types of data. We have what we call independent samples, which is what we'll focus on first. This is where we have different people in each group that we're comparing. So it's known as a between group comparison and an independent sample comparison. Whereas on the right-hand side of this figure, we have related samples. So essentially it's the same people and doing a before and after study, and that's a within-group comparison. So if you have a sample whereby you're just looking at individuals in one period of time, and every measure you've got in there is from a different individual, you would fall down to look at these tests. Whereas if you were following people over time to see what they look like, say at baseline, and then after an intervention, then you would look at a related samples kind of test. In the independent sample, so we've just got one measure for each individual in our sample. Again, we have our parametric and our non-parametric types of tests that we can do. So the parametric making assumptions about normality in our outcome, a normal distribution, whereas the non-parametric doesn't make that assumption. So if the data was parametric, we would run what we call an independent samples t-test. I've referred to the t-test before in some of the earlier presentations. The non-parametric equivalent of that is called the Mann-Whitney test. If we had related samples, so we've got before and after kind of study design, and again we have the parametric and non-parametric equivalents. For the parametric, we've got what's called the related samples t-test, and for the non-parametric equivalent, it's the Wilcoxon test. Now you'll come across these terms in SPSS, and this is particularly related if you go on and do ClinDoc project that has some quantitative element, and you're doing something like an RCT feasibility study, or you've got some kind of survey that you've carried out, you'll need to kind of understand and think about, and you'll be able to think about the types of tests you'll be able to do really early on when you're designing your study. So that will give you information to focus on, and so you don't need to know everything about Mann-Whitney tests or related sample t-tests if you know that your data has the potential to be parametric. You don't know that until you obviously do the study, so you might have to look at both the parametric and non-parametric equivalents, and you'll say you'll test for that and you'll run one of them. But if you know you're not going to have related samples, you're not going to do repeat measures, then you know you don't have to worry about these types of tests on the right-hand side. So that's just one way that, again, you can be a little bit strategic about what you learn in more detail. Essentially, these tests, the ones that are independent, whether they're parametric or non-parametric, are based off the same foundation. Again, as we mentioned, they're just not making the same assumptions in terms of normally distributed data, and the same for those related samples. So if we want to compare cholesterol between two sexes, men and women, in our data set, are these independent or related samples? Remember, they'll be related if it's the same people provide two sets of scores. They'll be independent if each individual only gives us one value in terms of their cholesterol. For example, patients complete a mental health questionnaire before and after counselling. Does counselling have an effect on the scores? That's where we then have a related, repeated sample. Our data comes from independent groups, so it's not a before and after design that you'll be looking at in the SPSS data that I've given you. Then we have to question, is it parametric or non-parametric data? So remember that parametric tests assume certain characteristics, that you have interval or ratio data, that the data is normally distributed, and they have this idea of similar variance, so the spread of scores. But that's kind of essentially covered within the normal distribution element. So let's have a look at comparing means and running a couple of tests with our data in exercise 7.